In the world of science and cosmic enigmas, the inquiry into what may have existed before the Big Bang has sparked debates and captivated minds for centuries. This profound question not only challenges our comprehension of the universe but also pushes the limits of human knowledge. Picture standing on the precipice of existence, gazing into the boundless void and wondering what lay beyond. Before our universe came into being, the moment of the Big Bang marked the commencement of time, space, and everything we are familiar with. But was there a moment preceding this? Could there have been a state of utter emptiness, a stillness, before the cosmic symphony began? Or perhaps something far more daunting existed before the birth of time itself? As we delve further into this inquiry, science leads us on an exploration beyond the birth of the universe, into theories that challenge our deepest conceptions. Physicist Brian Cox, known for his work on the wonders of the cosmos, proposes that something chilling could have preceded the Big Bang. He compels us to reconsider our notions of reality, time, and space. In this investigation, we will explore the science, the hypothesis, and the astonishing mysteries that may shed light on what came before everything. We will look into ideas such as cosmic inflation, quantum fluctuations, dark energy, and even the multiverse. The revelations we encounter could astonish you, but they may also reveal new perspectives on our place in the vast cosmos. Prepare to embark on a journey into a domain beyond imagination and science, where the unknown continues to loom, leaving researchers astounded and, at times, unsettled. Let us explore what may have existed before the Big Bang and why these theories challenge everything we once believed. To comprehend what could have existed before the Big Bang, we first need to carefully examine what the Big Bang itself truly was. The Big Bang, as scientists define it, refers to the instant when the universe became intensely hot and dense, rapidly expanding to spark the formation of all matter, energy, and cosmic forces. When we look up at the night sky, we see evidence of this fiery origin, with galaxies spreading out from a central point in all directions. But why did this occur, and was there a time prior to this dense, scorching beginning? According to the theory of cosmic inflation, there was indeed a before, and it was far from empty. Cosmic inflation suggests that, prior to the Big Bang, the universe was in a state that was cold, vacant, and extended, almost like an enormous void. However, this vacuum was not entirely devoid. It contained an enormous amount of energy that drove the rapid expansion of space itself. This process, known as inflation, occurred so quickly that it essentially set the stage for everything that would follow. In an instant, space expanded at incomprehensible speeds, until the expansion slowed and the energy transformed into matter, particles, and the forces we recognize as the Big Bang. But what was the nature of this energy? Why did it suddenly cause the universe to inflate, and why did it cease? Scientists theorize that this cosmic inflation generated regions of the universe, each undergoing its own Big Bang. Picture a vast fabric stretching endlessly, with tiny bubbles forming here and there. Each bubble symbolizes a universe, including ours. This notion, called the inflationary multiverse, suggests that there could be an infinite number of Big Bangs and an endless number of universes. Our own universe is but one of many. This colossal, mind-bending reality challenges our very understanding of the universe itself and leaves us pondering what else might be out there. The notion of nothingness before the Big Bang remains theoretical, at least according to our present understanding. Even if you were to remove all energy, particles, and radiation from the universe, it would still not be entirely empty. Our universe is filled with dark matter, dark energy, quantum fields, and other forces that create an inescapable web of somethingness, even in its most desolate form. Even if we imagine stripping away all these forces, leaving a dark void, the universe would still produce new forms of energy. This fact alone perplexes scientists, suggesting that true nothingness might be impossible in our cosmic framework. As we investigate further, we find that space itself has attributes, laws, and constants that prevent it from being completely void. Imagine attempting to create an area with absolutely nothing in it. No particles, no radiation, and no energy. But quantum fields and fundamental constants still persist, meaning that this nothingness would still possess characteristics. One such phenomenon is zero-point energy, the lowest possible energy state of quantum fields. In this state, particles can briefly materialize and vanish, leaving behind an ethereal trace of activity, even in what should be empty space. This undermines our concept of a true void, indicating that even before the Big Bang, there was something that scientists are just beginning to comprehend. One of the most remarkable ideas in contemporary cosmology is the concept of eternal inflation. If inflation could cause the existence of our universe, it is conceivable that it could persist indefinitely. Brian Cox envisions a terrifyingly expansive inflationary multiverse, where universes are endlessly created and continue to stretch. Imagine each Big Bang as a spark igniting a new universe, while inflation carries on elsewhere, producing countless other universes. This process could, in theory, continue endlessly. This idea of infinite universes gives rise to a captivating notion of a fractal universe, where every new universe has the potential to create its own Big Bang. Each universe exists as a distinct, self-contained realm, unaffected by the others due to the rapid expansion of space. For scientists, this hypothesis is both thrilling and disconcerting, as it implies an eternal multiverse with no definitive beginning or conclusion. What if our universe is merely a speck in a vast cosmic structure, expanding and creating endlessly? And what if the chilling truth is that there is no before or after, only an eternal cycle of universes forming and dissolving? Our understanding of nothingness is further complicated when we turn to quantum field theory. According to this theory, the universe is not merely a collection of matter floating in space. Rather, it is an intricate network of energy fields that permeate the cosmos, interacting to create all that we observe. These fields are akin to invisible oceans, with particles acting as ripples, waves, or disturbances. Even when fields are at their lowest energy level, known as the vacuum state, they remain active. Particles can materialize and vanish within these fields, borrowing energy briefly before returning it. This phenomenon gives rise to virtual particles, temporary entities that emerge and then disappear, leaving behind a faint echo of their existence. The notion of virtual particles challenges the idea of a true void. Imagine an empty universe where all matter, radiation, and energy have been removed. Would you have complete nothingness? According to quantum field theory, you would not. Even in a vacuum, fields would remain active, occasionally generating fleeting particles. This constant activity in what should be nothingness suggests that the universe does not adhere to our concept of emptiness. The fields and forces persist, filling the cosmos with an underlying energy that prevents absolute nothingness. This realization prompts a fascinating question. If fields give rise to particles and particles form matter, could the universe itself have emerged from this nothingness, filled with quantum fields? Dark energy, an enigmatic force that currently drives the accelerated expansion of our universe, could have existed prior to the Big Bang. Some scientists suggest that the dark energy we observe today may be a remnant of an energy field that existed before our universe's birth. Dark energy's characteristics hint at a hidden power that could have been present before the Big Bang in some form. Some theories propose that dark energy, in a much more intense state, could have powered the inflationary phase, enabling rapid expansion. The presence of dark energy implies that, even if our universe were devoid of all matter and radiation, this force would persist in stretching the fabric of space-time. This concept leads to an unsettling idea. If dark energy existed before the Big Bang, it might have shaped the conditions that led to the emergence of our universe. Could dark energy be the quiet architect of cosmic inflation, or even the true origin of our universe? As we explore this notion, we confront the possibility that dark energy may not only influence the creation of our universe, but also hold the key to unlocking the mysteries of the multiverse itself. Another theory offering an alternative to the Big Bang as the ultimate origin is cyclic cosmology, the idea that the universe undergoes endless cycles of birth, death, and rebirth. In this model, the Big Bang is not a one-off event, but part of a cosmic rhythm where universes expand, contract, and then re-expand in new cycles. This theory suggests that our universe could have been born from the remnants of a previous one. The process of contraction and expansion in a cyclical pattern means that there was never a true beginning, but rather an infinite sequence of universes emerging, evolving, and renewing themselves in perpetuity. Cyclic cosmology raises profound questions about the nature of time, suggesting that time itself could be circular rather than linear. If this theory is correct, it might imply that what existed before the Big Bang was simply another iteration of the universe, one that collapsed only to give birth to our current universe. For scientists, this theory presents an elegant resolution to the question of ultimate origins, suggesting that there isn't one. Instead, the cosmos has always existed in one form or another, transcending our notions of time and existence. Primordial gravitational waves are another intriguing concept that may hold clues to what existed before the Big Bang. Gravitational waves are ripples in space-time caused by massive cosmic events, and scientists believe that primordial waves, if detected, could reveal details of the universe's earliest moments. These waves would be remnants from the inflationary period, carrying information about what occurred during the first split second after the Big Bang. But what if there were waves that preceded even the Big Bang? Some hypotheses propose that gravitational waves could exist from a pre-Big Bang era, offering a glimpse into a time before the universe as we know it. Ultimately, what existed before the Big Bang remains one of the greatest mysteries in science. The search for answers will likely continue for many years, as theories evolve and new discoveries are made. Could the universe have always been here? Did it arise from a quantum fluctuation, a cosmic accident, or something even more extraordinary? Or does the true nature of the before lie beyond our current comprehension, in a realm where time and space as we know them do not even apply? As we persist in exploring the nature of the universe, one thing is certain. The quest for answers will shape our understanding of existence for generations to come.